This is Ray PCB, your current PCB partner. Today, we will continue introducing commonly used PCB parameter settings in KCD. We'll continue from the previous episode to introduce the three main options in the PCB editor. Let's start by opening the editor. Next, the display options. We already covered all of these in the last episode, so this time we'll start from the grid setting. First, the grid option is different from the schematic as it determines the spacing size. We usually use the default setting and don't change it. Next are the origin and axis. This option displays several origin settings. By default, the page edge is set as the origin. The x-axis increments to the right and the y-axis increments downward. Let's see what that means. Back in the PCB editor, the origin of the drawing is here at the top left corner. We can see the x, y coordinates here. When I place the mouse here, the x and y coordinates both show 0. So what does it mean for the origin to increase to the right? Moving to the right means the x value increases positively, and moving downward means the y value increases positively. Since all our components are in this area, we set it so the values increase to the right and downward. This makes it easier for us to calculate each coordinate, ensuring that all calculated coordinate values are positive. If we use another coordinate system, we can also adjust the way values increase according to the situation, aiming to keep the component placement area within positive coordinates. This makes it easier for us to calculate precise positions. Now, let's continue. The Edit Options menu contains a bit more content. Let's look at the first one, the Rotate command, which defaults to 90 degrees. Let's see what that means. It refers to the rotation of the component. For example, if I select this component, select the component, then rotate it. It rotates in increments of 90 degrees. So when I change this angle, for example, so 45 degrees, and then rotate again, it will rotate in increments of 45 degrees. This is mainly useful when the PCB board you're designing isn't rectangular, and the orientation of the components isn't in 90-degree increments. We need to adjust this value so that we can place the components in the correct orientation. After that, we should set it back to the default of 90 degrees. The second option is arc editing mode, which isn't particularly useful. We can just keep the default setting. Next, the mouse drag behavior is set to 45 degrees by default. Let's see how dragging works. What is the main function? First, select the line we drew earlier. Select it, then drag it with the left mouse button. It will always maintain a 45-degree angle with the other lines as you move it left, right, up, or down. Now let's see what happens with the other two options. The first one is a move. Select it again. This simply moves it away without keeping the original circuit connection. Now let's look at the other one. Free move. After selecting it, you can move the line at any angle. This is only used in special situations. Normally, we always use the 45-degree mode as default. Now, for the following options, they don't have much impact, so we won't go into detail about them. Now, let's look at snap to pad, which does affect us. By default, it's set to snap while routing. Let's see how this affects our selection when drawing a net. When you get close to the target pad, it will automatically snap to the pad. You don't need to click very precisely. This way you can easily complete the connection to the pad. Next, let's take a look at no assist. Let's draw another line. This time, you'll notice it doesn't automatically snap accurately to the center of the pad. so you'll need to zoom in and manually snap to the center of the part. This makes the drawing process less efficient. That's why we usually choose to enable Snap Assist when routing. Similarly, snapping to traces and vias works the same way. Just like connecting other traces and vias, the network will automatically snap. It's the same process, so we won't demonstrate it again. You can just proceed without any extra steps when routing. Next, there's another important option, which is this one. Show component outline collision when moving or dragging. What does this mean? Let's first look at it when it's checked. Select a component and move it. Return to selection mode and select the component. You can see that when two components collide, they turn red. This alerts us that these two components are colliding. In reality, component collisions can't happen on a circuit board, because if one component overlaps another, you can't solder both in the same spot. So this feature is very important. Next, let's see what happens if we turn off this feature. If you turn it off, there won't be any alerts, which isn't helpful for our design work. This is disadvantageous for PCB design, because sometimes there might be slight interferences, or when the component density is too high and components are arranged in two layers, it can be hard to see clearly, which can lead to overlapping connections. If there are no warnings, it could result in a final PCB that can't be used after manufacturing. So this option is also very important. Remember to check it. If you find that the software doesn't give a warning for overlaps, then this is the reason. Now, let's look at the next part. The next one is the color option. This really comes down to personal preference. Usually we don't change it and just stick with the default set, just like in schematic processing. But if you have special preferences, you can modify it. Finally, KiCad provides a lot of plugins which can greatly improve our design efficiency. For example, automatic routing. There are also plugins for generating arms, interactive setup, HTML, and so on. These can greatly improve design efficiency. As we continue, I'll gradually introduce which plugins we use as they come up. That concludes the entire introduction to PCB editing. If you enjoyed this video, please subscribe to my channel for more content. Thank you everyone.